Vulnerability assessment. Welcome. This chapter covers vulnerability assessment, how to prioritize findings, and safe, legal ways to test in labs. We're building on scanning and enumeration to find and rate real risks, produce clear remediation plans, and validate fixes, all with written authorization and safety-first methods. By the end, you'll understand the difference between discovery and assessment, how to triage issues, and how to practice exploitation responsibly in controlled environments. Learning objectives. In this short lesson, you'll learn 4 core things. First, how vulnerability assessment differs from scanning. Second, the common classes of vulnerabilities you'll encounter. Third, how to prioritize issues using impact and likelihood. And fourth, how to validate and practice safely in labs. Keep these objectives front of mind as we move from theory into hands-on, legal exercises and reporting templates. From scanning to assessment. Recap briefly: scanning and enumeration discover hosts, ports, and services. Vulnerability assessment is the next step, mapping those services to known weaknesses like CVEs, misconfigurations, or insecure defaults. Instead of just listing open ports, assessment asks, what could be exploited, how easily, and what would be the impact? That shift from discovery to risk-focused analysis is what separates reconnaissance from actionable security work. Vulnerability lifecycle. Every vulnerability follows a lifecycle: discovery, where scanning or reports surface a potential issue; verification, where we confirm it's real and not a false positive; prioritization, where we score and decide which to fix first; remediation, applying patches or configuration changes; retest, confirming the fix worked; and closure, marking the issue resolved. Good assessment focuses on verification and prioritization. Reporting dozens of possible issues isn't helpful unless you rank them so ops can act. Always include a retest step so teams know the issue is actually gone. Common vulnerability classes. Here are 3 high-impact vulnerability classes to recognize. Injection vulnerabilities let attacker controlled data run as code, for example SQL or command injection. Authentication and access control flaws let users gain more privileges than intended. Cross-site scripting and CSRF are browser context issues that can hijack sessions and perform unwanted actions. There are others: insecure deserialization, config mistakes, and missing patches, but these 3 recur often and deserve early attention. More vulnerability types and examples. Additional quick types to watch: configuration issues, exposed admin panels, default credentials, missing updates which map directly to CVEs, and information disclosure where sensitive data is visible in pages, headers or logs. These issues are often low skill to fix but high impact if left alone. When you run a scanner in a lab, it will usually flag these. Your job is to verify and prioritize. Prioritization, simple risk logic. Prioritization is key. Use a simple risk formula. Severity is impact times likelihood. Impact asks, what happens if exploited, data breach, service outage, or minor info leak? Likelihood asks, how easy is exploitation, remote, unauthenticated, or local only? Convert that into triage buckets: high, remote RCE, data exfiltration; medium, auth bypass with user creds; low, non-sensitive info leak. Use CVSS if you want formal scoring, but a quick impact likelihood check works well for daily triage and helps ops decide where to act first. Tools and what they do. Tools speed up assessment. Vulnerability scanners like Nessus or OpenVAS map services to known CVEs and suggest fixes. Web-focused scanners flag typical application issues. But tools are imperfect. Manual review of configs, headers, and source code is essential to remove false positives and to understand context. For practice, use scanners only against authorized lab targets and always interpret their output before reporting. Legal and ethical rules. This is non-negotiable. Always have written authorization before testing any system you don't own. Define scope: which IPs, apps, or domains are allowed and which assets are off-limits. Set safe hours and a point of contact. For learning, use isolated labs like OWASP JuiceShop, Metasploitable, Try Hack Me, or your own VM images. Never test production systems without explicit permission. Ethical practice protects you legally and keeps your work professional. Lab Exercise Overview. For hands-on practice, spin up an authorized lab such as OWASP JuiceShop. Run an authorized vulnerability scan, export the report, then triage the top 3 issues by impact and exploitability. For each, propose a remediation, patch, config change, or code fix, and retest after applying it. Keep all testing contained to the lab environment to remain ethical and safe. Reporting and Remediation Template. Your remediation report should be concise and actionable. Title, affected asset, and severity, a short technical description and business impact, a recommended fix, patch versions, config changes, or code actions, and status fields for tracking. Avoid including full exploit steps in public reports. Keep reproduction details in an internal appendix for developers and operations to replicate and fix. Final best practices: automate routine scans but always verify tool results manually. Prioritize high-impact fixes first and document remediation steps. Keep practicing in lab environments and always obtain written permission before testing real systems. If you want, in the next lesson we'll build a sample remediation report together and walk through a safe lab retest. Thanks for following, stay ethical and keep learning. Now that you understand vulnerability assessment and how it strengthens cybersecurity, it's time to take the next step in your ethical hacking journey. Don't stop here. Subscribe to our channel, like this video, and share it with others who want to learn ethical hacking the right way. Together, we can build a community of skilled, responsible cybersecurity experts who protect and innovate in the digital world.